Now, I think we can all think back to a time in which someone told us that one of the most important things we can do in this country is to go out and vote, to have our voice heard, and to participate in civic engagement. And every single time I've heard that, I've always felt empowered, knowing that even in 2026, with polarization in politics and society high, that the people still hold power. And foundationally, that is one of the biggest reasons we established this country in the first place. When our founding fathers settled in North America and were thinking about possibly creating a country, one of the things that really pushed them over the edge to do exactly that was how the tyranny of Britain continued to restrict them of even the most basic of rights, like being able to have a say in the way they were being governed. So we announced our independence to break away from those bands of a tyranny and to establish a country in which we can guarantee a government governed by the people, and that the people hold absolute authority, manifest in the ability to have equal opportunity in a fair election, regardless of race, sex, religion, or location. Yet sadly enough, in 2026, it seems as if there is but one thing that continues to restrict our ability of upholding that foundation in the highest manner possible: gerrymandering, as it is impeding our ability to have fair elections in the US. So we gather here today to dive deeper into what exactly gerrymandering is in the first place, and to focus on an important intersection with gerrymandering and mathematics. Now, let us first establish why having that kind of approach is important. Because oftentimes when it comes to the discussion of gerrymandering and whether a congressional map possibly has been gerrymandered, there's a lot of political rhetoric that often goes into it. And sometimes that can actually bog down the objectiveness of something that can simply be determined if you come from a more statistical/mathematical approach. And all of that happening inevitably results in us not being able to see the negative effects from there being an inefficient congressional map. So that is the main goal of this portion of the presentation, being able to view congressional maps from a more statistical and mathematic approach to determine possibly if gerrymandering might have happened without having to go through all the political rhetoric that often bogs down the process of doing exactly that as a whole. But before we do that, we need to first establish generally what a fair district or fair map in general should look like. Well, the biggest goal that our legislator in general in Congress should do is being able to reflect voters in a state. A lot of voters, when they go and vote, they vote for specific congressional members in the hope that in the future they'll pass legislation that is in their district, in the best interest of their district. So if we have a truly fair map, we need to be able to proportionally reflect the given voters for a state. Next, we need to be able to accurately translate votes into seats. And that often is really closely tied to being able to reflect the voters, except that when we translate votes into seats, we need to have a level of proportionalness along with it. Meaning that if we have about 60% of a state that voted Democratic in a given map election, we could expect that about 60% of the seats should be Democratic. That would be a high level of efficiency and proportionality, which would be effectively translating votes into seats. And the last thing we see is to avoid large distortions. A lot of the times we don't have to really deal with a lot of distortions when it comes to the way that the map is physically drawn, unless there's clear signs of gerrymandering. So those are the three things that we need to guarantee in order to see a fairly fair map. Yet oftentimes we see that in some congressional maps, they aren't efficient. So let's kind of establish a mathematical approach to see if a given congressional map is actually, efficient. In the last slide, we talked about how we need to be able to reflect the voters in a given state with a sense of proportionality. So let's look at the situation we have on the board, which oftentimes happens in many elections around the country. We see that the statewide vote share for this given election goes as the following. About 47% of all the people who voted in a given state election are Republican, while 53% of all the other voters are Democratic. Again, if we go strictly back to the goal of what Congress is in the state and federal government, it is mostly to reflect the voters. So you would expect that translating these votes into seats, we would have a sense of proportionality. That about maybe 50 to 47% of all the seats should be Republican. Yet in this example, the opposite actually happens. Even though Republicans only make up about 47% of all of the votes in a given state, they actually represent 86% of all of the seats in a given election, meaning that Republicans are being massively overrepresented, while Democrats, on the other hand, who make up 53% of votes in a given state, only make up 14% of the seats. So they're being underrepresented. Now we take a step back and see that our goal of proportionality and reflection of the voters in this election is being completely dismantled. So let's make a more statistical approach and kind of set a median. So we have a formula right here that is going to actually calculate the seat-vote gap, and we're going to get a percentage out of that. So using this example, let's calculate the seat-vote gap. We see that the seat share for Republicans is 86%. Go ahead and do that. Oops. Okay, so the seat for Republicans is about 86%. And we are going to subtract that by the vote share, which is 47%, minus 47%. And that is going to equal 39%. Now, that alone doesn't mean anything, but 39% is an extremely large seat vote gap. So let's kind of give that percent we calculated from this formula a little bit more context. Let's say that a really good, efficient congressional map should be able to, when you calculate this, have a seat gap of about 0 to 5%. But let's be even more favorable and say that things happen, there can be shifts with votes. A general, good, decent map should have a general seat vote gap range of about 0 to 10%. So let's say that 0 less than or equal to percent that we calculate from this formula, 10. And if we have our percentage between 0 and 10, that would mean that we have an efficient map. So if we get this formula and we take our numbers and calculate it, and we get a percentage that is within the range of about 0 to 10, we can come to the general conclusion that we have an efficient map when it comes to reflecting the voters in proportionality. On the other hand, we see that the percent we have is 39%. So let's say that any number we get from 10 with our percentage within the maximum number it can possibly be, which is 100%. We're not going to really see examples of 100%. If we have a percentage within that range, then we can come to the conclusion that the map is not efficient. It is failing at the goal of proportionally representing the given voters in an election. And we can see that we have a pretty high percent from this given example. 39% is well above 10. And we know that ranges from like 50% to 60% are really going to be extremely inefficient maps. So now that we have a general idea of how to calculate how a map actually is when it comes to efficiency, let's go ahead and look at a real example with Pennsylvania. This is the 2016 federal representation vote. And sadly enough, in 2016, we had a pretty gerrymandered map, both federally and at the state level. And that's one of the big reasons we established Fair Districts PA, to speak out about gerrymandering. So if we look at this example, we see that the given votes in 2016 for a real Pennsylvania election resulted in about half of the states being Democratic, half of the votes being Democratic, while the other half were a little over Republican, around 51 to 52%. So again, if we have an efficient map and we're speaking strictly with the goal of what Congress is, to represent the people, you would expect that the results of these elections would be about half of the seats being Democratic and about the other half being Republican. Yet again, we see that the opposite actually happens. Even though Democrats make up about half of all the votes in a given state election, they only win 1/4 of the seats. So they're being massively underrepresented. While Republicans, who make up a little over 50% of the votes, make up 3/4 of the seats actually won. So if we were to do the calculation with the formula before in our head a little bit, it would be from the range of about 20 to 25%. So meaningfully within the domain of what we would see an inefficient map result. But us calculating that percent only tells us one thing: if a given map is efficient or if it's not efficient. It doesn't tell us what actually caused that discrepancy we're given. And there's three main things that can really cause an efficiency gap on that level. One, a congressional map truly was just written terribly. One almost never happens. We have extremely smart people that sit down and write these maps. There's a very small chance extremely smart people are just going to sit down and draw lines on a empty state map, and it's going to be really bad. But we could come to the conclusion that maybe one happens if we have more context of the situation and the other two don't happen. Number two, there is an anomaly in the election that causes the votes to shift in a certain way. Now, there are some examples of number two happening, and we'll be able to come to that conclusion again with a little bit more context on the situation and that there isn't a clear sign of number three happening. So really, we are able to establish why a congressional map is either inefficient or efficient based on number three, which is if there was gerrymandering or not. Usually, almost all of the time, when there is that big of a seat vote gap and the efficiency is just terrible, partisan gerrymandering happened. A map was made inefficient on purpose in order to over-represent a group of people. So if that does indeed happen, we know the first two didn't happen. And if gerrymandering didn't happen, then we can look deeper into the given situation and we can come to the conclusion if either the maps were just really made bad or if an anomaly happened and the votes actually shifted the other way. So in the status quo, there are two main ways that gerrymandering happens: cracking and packing. So what we are going to try to establish is this: if we have an inefficient map and we see clear signs of gerrymandering, then we can come to the conclusion that gerrymandering is extremely probable. So cracking and packing will require us to look deeper into the actual vote spread for a given election. Now, what cracking is the people who make a given congressional map will try to take the assets of the opponent and spread them thin in all of the votes, meaning that the votes in many of the districts in the states will be close, but the opponent will always lose because they'll always come up about 2 to 3%. Now, that isn't by chance, it is made on purpose. And when you see that consistently happening over many, many districts, that's basically clear signs of cracking. While packing, on the other hand, is where a person who makes a congressional map seeks to take all of the assets of the opponent and put them into one or two districts. So yeah, that the opponent wins those two districts massively, but in doing such, they actually waste all of their assets and votes. So they no longer have votes to spread around the actual state. Let's look at this example right here with cracking for my home state, Nevada. I think it's a really nice example and it gets the point across. So there are 4 districts here, and we see that in this example, yellow wins 3 of the districts and green wins 1. Now, yellow and green actually have an equal proportion of dots. So we need to write these districts in a way to give yellow a clear advantage, even though green and yellow both have the same number. So if we look at this top left-hand corner, yellow has 3 dots and green has 2. The next one, yellow has 3 dots, green only has 2. This one, yellow has 3 dots, green only has 2. A very systematic approach that each one of these districts, yellow wins only by a little bit, while green is coming up extremely short. Then, since we have 3 districts that we won easily, there has to be at least one district that we're going to lose, and that's why green wins that one. But the people who wrote this map made it so that green came extremely close in the election, but they basically guaranteed that green was going to lose the election from spreading their assets out in a way that they run thin. On the other hand, in this situation, we see that green wins 3 of the districts while yellow only wins 1. Let's look at this top left-hand district right here. There is not one green dot in that district. They're all yellow. There's 5 yellow dots in that district. So yellow won this almost unanimously by a huge margin. But In doing such, they wasted a lot of the assets they would have needed to win all the other districts, and that is packing. So the other district that's by this huge one, green has about 3 dots, and yellow has 2. Green right here has 3 dots, and yellow has 2. And in this one, green has 4 dots, and yellow has 1. So with all the other districts, basically yellow just doesn't have any more assets because they wasted them all on that one, and that is packing. Going back to that same exact election we saw with the huge inefficiency gap from the seat gap, we see that when we take a deeper look at the margins of which the districts actually went through the election, that there are possible signs of packing here. Let's look closely. So we have PA District 1, PA District 2, and PA District 14. And if we remember back, Democrats were being underrepresented while Republicans were being overly represented. So if we have that conclusion, we're going to now look at this kind of graph to see how much Democrats actually lost by in the given elections and possibly see if we have signs of either cracking or packing. In this example, we have 3 districts for Democrats. In this one, Democrats won by 82.2%. In the next one, they won by 90.2%. And in the last one, they won by 74.3%. These are huge margins. Let's look at Republicans' wins on the other hand. Republicans in PA 6 won by about 57.3%, while in PA 8 they won by 54.5%. In PA 16 they won by 53.9%. A lot more efficient. They're not winning by tens of thousands of votes, so they have a lot more voters that they can spread around the state. Now let's look at the amount of voters in these packed districts Democrats actually won by. In this district right here, there were 138,000 Democrats. That's a lot of voters for one district. While if we come over here, all of the Republican districts are within range of about 25,000 to 10. That is a huge margin, once again, of how many voters are physically within these districts. So while the Democrats win these 3 districts massively, they no longer have votes to spread around the state. And because of that, Republicans are going to constantly win a lot more districts and then in turn be massively overrepresented. So the main goal that we have now is putting it all together with cracking and packing, along with taking the general efficiency of a given election. Our goal is to see that after an election with the congressional map, if we can see that possibly gerrymandering happened without dealing with any political rhetoric, but focusing on the mathematics part of it and statistics. So let's kind of create a logical approach to see what would be needed in order to come to a conclusive opinion or approach that gerrymandering possibly happened. We're going to be using a little bit of Boolean algebra with conditionals. So let's say that we calculate the efficiency gap and we get a range of 10 and our percent. So our percentage is within that range of either 10 to 100, and let's say our percent is 45. So that is the first thing that must happen. And we need one more thing in order to come to the conclusion that gerrymandering possibly happened. Again, that is only the effect of what actually caused the efficiency to happen in the first place. So we have the effect right there. We need to establish the cause. So the cause in this example that would result in us coming to the conclusion that gerrymandering actually happened is if there is clear signs of cracking or packing. And that's another statement in itself, that part right there. Both of those two things can't happen. One of them has to happen, right? And in order for us to come to the conclusion of a high percent chance of gerrymandering, we need these two things to happen. We need to get a percent of within the range of 10 to 100%, and we also need to see clear signs of cracking or packing in order for there to be a high chance or probability of gerrymandering. And that's a more logical approach we can take in order to come to that conclusion. So let's see if we can now come to the conclusion conclusively for that 2016 Pennsylvania election that there's a high probability of gerrymandering. Let's first see if the map was efficient or if it was inefficient. In that example, using the exact data from the pie chart, we see that the seat share was about 73.3%, minus the vote share of 51.63%, gives us a percent of the efficiency gap of 21.7, which is well within that range of 10 to 100. That would mean we have an inefficient map. So we have a clearly inefficient map that isn't proportionally reflecting voters. The next thing we need is evidence of either cracking or packing. And we got that in the last example when we were looking at the amount that Republicans won compared to Democrats. There were clear signs of packing in districts PA1, PA2, and PA14. So now, because we have those two things, we have the effect and the cause right there, we can come to the conclusion that because we had a high seat vote gap and clear packing evidence, that more than likely the 2016 Pennsylvania federal election was gerrymandered in Pennsylvania. And that is how we can come to a conclusion about gerrymandering, strictly focusing on statistics, mathematics, and logic, which are the essence of STEM.
Yeah.